In this video, I'm going to go through the solutions to mini tests 1.1, 1.2, and 1.3 versions 1 and 2. The first question is asking us to determine if each of the following relation is a function, yes or no, and we're also going to explain. The first one, which is A, as we know, this is a quadratic equation, so the graph is going to be a parabola, which is going to look like a parabola which is opening upward. And we know that when you draw the vertical lines, it's going to cross the graph only once, so this is a function. So the answer is yes. The second one, which is B, is the graph which is given here. If you draw the vertical line, this is going to cut the graph only at one point, except when we get to a point here, which is going to be crossing the graph at more than one point. So this means that this graph is not a function, does not represent a function. It's just a relation. The next one is an ordered pair, which if you look at the graph, you can see that for every x, there is only one arrow coming out of the x. So this means that every x is having a unique y value. So this is a function. Just remember, although the y values, some of them they have more than one arrow going to it, does not mean anything. The only thing which is important to us is the x values. So number C represents a function. Now the second question says state the domain and range for each relation here. The first one, this graph, since it doesn't have any arrow at the end like this or here, there is no arrow, then it means that the graph stops at the left and the right. It doesn't go to infinity. So this means that the domain D is equal to x in R, and x is less than or equal to, if we count the number of units to the right, it's 1, 2, 3, 4, 5. So it's less than or equal to 5. And it's greater than or equal to, if we count the number of units to the left, it's 1, 2, 3, 4, 5, so it's negative 5. Our range is going to be starting from the top. If you look at the top, you can see that this is here is equal to 4, so y is in R, and y is less than or equal to 4, but it's greater than or equal to negative 2. So this is our domain and range for the first one. For the second one, it's an ordered pair, so the domain are 1, 0, negative 1, and negative 2, and the range are 4, negative 5, 3, and negative 3. The next one is the graph C. You can see that there is no arrows at the end of the graph, so the graph ends and it doesn't go to infinity. So you can see that a D is equal to x in R. Now the x values, they go from this point, which we can say 6, and they start at 2. So x has to be less than or equal to 6, greater than or equal to 2. And also they go from here, which is negative 6, so x has to be greater than or equal to this point, which is negative 2, and greater than or equal to negative 6. That's our domain. Our range is going to be equal to y in r. Now our y value, they start from this point and they end up here. So y has to be between 3 and -3. The next question says, consider the function g of x 3x over 2 plus 1 and h of x is -2x squared plus 5x minus 1. Part A says find g -3. G -3 is just the value of the function g when x is substituted by -3. So we're going to say g -3 is equal to 3 times -3 divided by 2 plus 1, which is -9 over 2 plus 1 can be written as 2 over 2. So this is -7 over 2. For h of -5, we are going to evaluate the function at x equal to -5, so it's going to be -2 5 squared plus 5 times -5 minus 1, which is -5 squared is 25 times -2 is -50. 5 times -5 is -25 minus 1, which is going to give us -76. The next part of the problem says find g of -3 plus h of -5. We found that g of -3 is -7 over 2. And h of -5 we found is -76. So if I use the common denominator of 2, it's going to be -7, but 76 has to be multiplied by 2, which is -152, and -152 minus 7 is -159 over 2. Part D says find x if g of x is -11. G of x by definition was 3x over 2 plus 1, and we want this one to be -11. I move this one to the right. I get 3x over 2 is equal to -11 minus 1, which is -12. Now if I cross multiply, I get 3x times 1 is 3x, and -12 times 2 is -24. I divide by 3, and I get x is equal to -8. The next question says, using completing square, determine the coordinate of the vertex, state the domain and range of the function. To use the completing square, we know that the leading coefficient has to be 1, so I have to factor -2 out. So I'm going to get -2 open bracket x squared plus 3 over 2x plus 5. Now I have to divide 3 over 2 by 2, so I'm going to say 3 over 2 divided by 2 is the same as 3 over 2 times 1 over 2, which is 3 over 4. So I'm going to add the square of 3 over 4, which is the same as 3 over 4 times 3 over 4, which is 9 over 16. I add and subtract. So I'm going to say -2 x squared plus 3 over 2x plus 9 over 16 minus 9 over 16 plus 5. Now I'm going to put a bracket beside the first three terms. These three I can represent it as x plus 3 over 4 squared minus 9 over 16 plus 5. Now I'm going to distribute -2 inside the bracket. I get -2 x plus 3 over 4 squared. Now -2 times -9 over 16 is plus 18 over 16 plus 5. Now, to add 18 over 16, I'm going to multiply 5 by 16 divided by 16. I get negative 2 x plus 3 over 4 squared plus 18. Now 16 times 5 is 80. Now 80 plus 18 is 98 over 16. I can simplify by 2. I get 49 over 16. So this one becomes negative 2 x plus 3 over 4 squared plus 49 over 16. So this means that the vertex is negative 3 over 4 and 49 over 16. The domain, as we know, this is a parabola, so there is no restriction on the domain, so the domain is x in R. And the range, if you look at the parabola here, the equation, because it's negative 2, it opens downward, and the vertex is negative 3 over 4 and 49 over 16. So this means that the range has to be y less than or equal to 49 over 8. I made a mistake here. When you divide this fraction by 2, this becomes 8 and this is 8. So here it is really 49 over 8, and the range is y in R and y less than or equal to 49 over 8. So this one becomes 8 too. The next question says the population of a town in thousands t years after 1998 is given by the following equation: 240t plus 50 divided by 3t plus 4. What was the population in 1998? We know that t is the number of years since 1998, so in this case we know that t is 1998 minus 1998, which is going to be 0. So p of 0 is 240 times 0 is 0, which is 50, divided by 3 times 0 is 0 plus 4. Now if you divide this one, remember that the population, this value is in thousands, so you really have to multiply this by 1,000, and this gives you 12,500 is the population in 1998. The next question says determine the population of the town in 2002. Again, we know that t is 2002 minus 1998, which is going to be 4. So we have to evaluate the function p of 4, which is going to be 240 times 4 plus 50 over 12 plus 4. But remember, again, you have to multiply it by 1,000. This is going to give us 63,125. The next question is saying, in what year will the population reach 72,060? Again, since the equation, the population is in thousands, you have to divide this number by 1,000 and then find t. The equation that we have to solve is 240t plus 50 divided by 3t plus 4 equal to, but 72,060 divided by 1,000 is 72.060. Now we are going to cross multiply, and we're going to get 240t plus 50 is equal to 216.18t, because 3 times 72.060 gives us 216.18t plus 288.24. I move this one to the left, this one to the right, and change the sign. I will get 23.82t is equal to 238.24 divided by 23.82. And from here, t is approximately 10 years. This means that the year that the population is 72,060 is 1998 plus 10, which is equal to 2008. The next question says that the student council is selling t-shirts. All proceeds from the t-shirt sales will be donated to charity. The t-shirts currently cost $22.50, and they sell 30 t-shirts at that price. Now they decide to decrease the price by $1.50 every time, and every time they do it, they will sell 6 more t-shirts. The first part of the question says how many t-shirts need to be sold to maximize the donation. Let's call R to be revenue. So we know revenue is equal to the number which we sell times the price of each one that we sell. If there is no decrease in the price, we know that we are going to sell 30 t-shirts, so we're going to write 30 here for the price of $22.50. Now we decide to decrease the price by $1.50. Let's say X represents how many times we decrease the price by $1.50. So if we decrease it by 1 time, it's going to be 1.5 times 1. If we decrease it 2 times, it's going to be 1.5 times 2. But every time we decrease it, we are going to sell 6 more t-shirts. So the number of t-shirts sold now is going to be 30 plus 6x. X again represent number of times we decrease it. And the price is going to be $22.50 minus 1.5x. Now we are going to expand this one and simplify. You can go ahead and expand this one. If you expand it, you get negative 9x squared plus 90x plus 675. Now, since we need to find the number of t-shirts to maximize the revenue, we have to find the coordinate of the vertex. So v of x, by definition, is the shortcut is minus b over 2a, which is minus b, which is minus 90 over 2a, 2 times negative 9, which is going to give us 5. Since we need to know the number of t-shirts, and the number of t-shirts is here, 30 plus 6x, so the answer is 30 plus 6 times 5, which is 60. So this means if we decrease the price 5 times, then the maximum t-shirts sold is 60 t-shirts. The next part of the question says, what is the price of each t-shirt that maximizes the donation? Remember, the price was $22.50 minus 150 times x. X we found to be 5. If you simplify this one, then it's going to give you $15. The last part of the question says, what is the maximum donation? We know the maximum donation R, revenue, is going to be the numbers sold. We know that the numbers sold is 60 that we found in part A, and the price per t-shirt, which we found in part B to be 15. If you multiply these two, it's going to be $900.